Students, welcome back to part B of the video. So we left off in part A where we're trying to get the distance of the bike stations bike stations to the three kiosks in a scenario where we're going to build three kiosks. So the scenario where we're going to build three kiosks, we want to know what the distance is of each bike station to those kiosks. And we ran the distm function from geosphere package to basically get the miles, the miles. And basically, if you look at row one, right, if you look at row one right here, the first bike station, we already know based on its cluster, based on the cluster that was given, it was assigned to, which station it's going to be closest to, right? Which station is going to be closest to. But again, this is for our analytics so that we can tell our client, look, if you have three kiosks, day one, this is your analytics around the distances between the kiosks and the bike stations. If you have two kiosks, this is your analytics, or whatever, five, six, we're doing two and three, but theoretically, you could do seven, eight, whatever, of these kiosks versus the bike station distances. Then if you have a multi-stage approach, right, to build two, then three, this is how your numbers would be affected. All right, so here we created a matrix. Again, a matrix is basically like it's basically like a vector, but it's a two-dimensional vector, right? And now we're basically going to load up this vector into what? Into our table. We have our bike table, we have this matrix, and basically how do we load this up? Well, this is interesting. What you could do is we could load it directly into bike and before, right? We're going to make three columns because we have three columns right here. And we're going to basically have K3, meaning if we do build three kiosks, build three kiosks, build three kiosks. And one means that if we build three kiosks in the three kiosk scenario, this is the first kiosk, the second kiosk, and the third kiosk. That's basically the notation for the columns. And this is a new interesting function we're going to use to make these three columns out of that matrix. This is called as.data.table. Right? It's basically the table.command, but as.data.table. Anytime you see these as.functions in R, they're functions that convert data types into another data type, or one type of data container into another data container. And that's basically what's happening here. This REST matrix is going to be created into a little tiny data table, which will then get fused into our big bike data table. Right? If I copy and paste this right here. Right, and again, we're doing this so that we need these numbers to compare our different version scenarios of our project. All right, boom. Oops. Oh, sorry, res matrix 3. I slightly changed the notation for my code. All right, right here. Boom. We have our data. Easy peasy. All right, so now, what are we going to do next? Well, you guys know what we're going to do next. We're now going to do the, take the distance. From here, we're going to create a column, another column called C3 cluster 3 distance, where the value will be gotten from either K31, K32, or K33, according to what cluster the value is in cluster 3. For example, right? For example, the first and second row, it will be from K33, in this particular example, right? And we see that again because, did I jump the gun here? We see that here again because what's going on here, the third kiosk is the closest one. We know that. It's telling us that. So we want that. We want that. I mean, I call this C3 distance. What I should call it is K3 min. All right. I don't want to change. Let's see if I change the column names. I don't want you guys to get confused in the slides. All right, we'll keep this. We'll keep this notation. What I mean by C3 distance is when you have for the cluster 3 group, when you have three clusters, what's the minimum distance, right? When you have 3 clusters, what's the minimum distance? We know that, right? This is kind of easy to do, right? We can do it like this. I could say, hey, wherever the cluster is 1, right, give me the distance. C3 distance is going to be the K31 column. Wherever cluster 3 is 2, make my C3 distance this column. And wherever cluster 3 is equals 3, make it this column. All right, relatively easy. Oh, next, got it. Boom. And again, we have our minimum distances. And now my live data, you can see it. Right here, 2 is the closest one. Yeah, of course it is. There it is. 2 is the closest one. There it is, and there it is. Again, why are we doing this? Because again, we want to compare our analytics for the minimum and maximum distances between each bike station and the kiosks when we have 3 kiosks, 2 kiosks, and our 2-step process. So basically, we're setting up the table to answer these questions for our clients, basically. Like, okay, if we have 3 kiosks, right, what's the average minimum distance? And now we have a column that can answer that question, right? We have a column that can answer that question. That's basically what's going on here. All right, now we're going to run this. We're going to run the analysis back, but this time we're going to do it for 2 kiosks. Same thing like we did before. We're going to run it back for 2 kiosks. Grab this. Change the rest matrix 2. Yes, yes, yes. This is the 2 one, and everything else is fine. Boom. Warnings, that's fine. Grab this. And now, instead of, if you look at rest matrix 2, instead of 3 columns, ladies and gentlemen, you're going to have 2 columns, right? Because there's only 2 clusters, two kiosks you're comparing with instead of 3 kiosks, all right? So here now I'm going to change this to K2. The notation is going to be K21, K22. I'll get rid of this right here. This is now rest matrix 2. All right, do this. All right, excellent. And now we can run that analysis back again. And this time we do plus 2 C2 distance. We're going to name that column C2 distance, okay? Plus 2, plus 2, C2, C2, K21, K22. All right, boom, boom. Now if I type in bike in here, look what I have. I have a column that's where are you? C3 distance. This is the minimum distance for, this is basically the closest in miles for each bike station to its kiosk. And now we have C2 distance is basically the closest distance for each bike station to the closest kiosks in terms of miles, if there's 2 kiosks. All right, so we have set up those 2 columns to set up our analysis and give some sort of feedback and analysis to our clients. All right, now look. Now that we have our minimum distance, the K21 and the K22 columns we don't need anymore, right? The K21 and the K22 columns we don't need anymore. The K31, K32, and K33 columns we still kind of need because we're going to be using those columns to figure out which 2 in our third scenario, which if we want to build 2 kiosks, if we want to build 3 kiosks, if we want to do it in 2 stages, build 2 then the third one. So we still need that data for our third analysis, our third scenario analysis. But the second scenario, we're pretty much good. So we can delete those columns. And deleting those columns is relatively easy, guys. You just basically select the columns you want, one or more, and you set them equal to null. And that's how easy it is to delete columns in data tables. And that's it, you're done. If I do click type bike here, notice those two columns are gone, right? Very easy. All right, so now we have the bike table, and we have something that looks like this. We have something that looks like this, all right? Now, this part is slightly more complicated because now we need to answer the question for the two-step process. We have the answer, we have the data to answer the question for 3 kiosks and 2 kiosks. We don't have the data to answer the question for if we do a two-step process, All right, so here, how do we proceed? Well, the question here becomes which two do we develop first, right? Visually, I showed you visually, I have a graph something like this, that we know that the kiosk 2 should be one of the kiosks built in, or in this case, this one, in this particular display, that this should probably be one of the ones built. But what about the other ones? What about the other ones, right? We're not necessarily sure, but quantitatively, but visually, this looks like we should definitely build this one first. Just because whether it's 2 or 3 kiosks, it looks like there should always be a kiosk in this location, right? It looks like the toss-up between one of these two ones right here. All right, so how do we go about doing this, right? So the way you want to approach this, from a mathematical point of view is we want to build the kiosk. We want to build the 2 kiosks, right? Remember, if you have 3 kiosks and you're going to build 2 out of them, right? Then we're possibly looking at 3 scenarios, right? 1 or 2, 1 or 3, or 2 or 3, right? We're looking at any one of those 3 scenarios, okay? So basically what you want is you want to build the 2 kiosks that contribute the least to the minimum distance. The least to the minimum distance. What do I mean? Well, for example, let's say if I build kiosk 1 and 2, right? Kiosk 1 and 2. The average distance that if I build kiosk 1 and 2 would add to the average minimum distance from the bike station's kiosk. Let's say if I build 3 kiosks, and let's say if I built the 3 kiosks, the average minimum distance from each bike to its respective kiosk, or the closest kiosk, let's say it's 2 miles or 1 mile, right? But let's say if I build just kiosk 1 and 2, right? Then that average minimum distance goes from 1 mile to 1.5 miles, okay? But if I build kiosk 1 and 3, then that average minimum distance goes from 1 mile to 1.2 miles. So which one contributes least to the minimum distance? It's the combination of kiosk 1 and 3 versus kiosk 1 and 2, which becomes 1.5 miles. That's the logic. I want to build the 2 kiosks that such that the minimum distance contributed to the average minimum distance overall to all the bike stations to their respective closest kiosk will be the least damaging. That's basically the way to approach this. All right, so how do we figure this out? All right, so how do we do this? Very simple. So let's use this example right here. Very simple example. 3 kiosks, 3 bike stations. 1, 2, 3, 1, 2, 3. Right, here's a different here's the distance, right? This bike station, here's the distance from this bike station to this kiosk, bike station 2 to this kiosk, bike station 3 to kiosk 1, 2, and 3. And obviously these lines are dictating the distances. So this is 5 miles, 4 miles. Bike station 2 to kiosk 2 is 1 mile. To 3 it's 3 miles, etc., etc., etc. All right? So let's start this off. How do we start this off, right? we started off by saying, okay, we calculate that the minimum distance from each bike station is, we first get the minimum distance from each bike station to its respective kiosk, right? So we come up with a nifty little table right here, bike station 1, 2, and 3, and here we can see for bike station 1, its minimum distance is to the third kiosk is 4. Bike station 2, it's 1, right there. And bike station 3, you have actually 2 minimums, 2 and 2, so you can choose either one, doesn't matter. 2, boom, done. So the average minimum distance, if we take the average of these minimum distances, if you have 3 kiosks, is 2.3. Okay? Now what we do is we remove one kiosk at a time and recalculate the minimum distance. All right, that's what we're going to do. We're going to remove one kiosk at a time and recalculate the minimum distance. All right? So we start off the first example. We take away kiosk 1. Take away kiosk 1. Now what's the new minimum distance? Okay, if kiosk 1 doesn't exist, bike station 1 doesn't affect it, still 4. If kiosk 1 doesn't exist here, again, for bike station 2 does not affect it. It still has its minimum distance being 1 over 2. If bike station 1 doesn't exist, okay, it doesn't affect bike station 3. Fantastic. The minimum distance don't change. The average minimum distance is still 2.3. Fantastic. I mean, we pretty much have our answer at this point, but let's just go on with the exercise. I should have made this kiosk 3. I should have switched it for more of a excitement to the analysis, but let's continue. So from here, I'm going to say, all right, kiosk, let's say there's no kiosk 2. Get rid of kiosk 2. Let's rejigger the analysis. Here, if there's no kiosk 2, again, bike station 1 is not affected. Its minimum distance still 4. Here, if there's no kiosk 2, okay, bike station 2 is affected. Now, bike station's 2 closest kiosk is 3 with the minimum distance of 3. So that gets changed over here. And over here for 3, no kiosk 2 has no effect on it because bike station kiosk 3 is there and it's the same distance. So that stays unchanged as 2. And the average minimum distance now for all these bike stations is 3. Okay, now we go to kiosk 3. And then we go to this third scenario where there's no kiosk 3. And recalculate the analysis. For bike station 1, that's severely affected. There's no bike station 3. Now, both this kiosk give it a minimum distance of 5. For bike station 2, there's no kiosk 3, so now we're back to 2. So that's good on its part. Its distance is 1 mile. And for bike station 3, there's no kiosk 3. Again, it's unaffected because kiosk 2 is there at 2 miles away. And so that's 2. And so this average minimum distance is 2.67. All right? Now, which kiosk, if we don't build it, will have the least effect, right? The least increase to the average minimum distance? It's kiosk 1. In fact, not building kiosk 1 has no effect on the average minimum distance. I mean, in this scenario, you got to ask yourself, hey, do we really need the kiosk 1 in the first place? Let's just scrap those plans altogether, right? Here, kiosk 3 contributed the second most. If we don't build kiosk 3, that contributed to the second most distance on average to all the bike stations. And obviously, not building kiosk 2 was obviously the most devastating because it increased the average minimum distance by the most. All right? So in this particular example, we're going to actually build kiosks 2 and 3. And honestly, I would probably tell my client, listen, we don't even need kiosk 1. Just leave kiosk 2 and 2. Save yourself some money. Right? But that's basically the logic, the algorithm we want to use to figure this out. All right, so let's go ahead to do this to figure this out. It's going to get a little crazy. So let's go ahead and take away the, let's create a new table called STA station dist, STA-DIST for station distance. We're going to just take these 4 columns, cluster 3, K31, K32, and K33. Because, again, obviously we need these 3 distances because we're basically going to rerun this analysis all over again, right? Excellent. Nice and smooth. I like that. Now we want to find the 3 scenarios, guys, all right? We want to find for kiosk 1 bike stations, find the smaller distance between kiosk 2 or 3, right? Now we want to say So basically what we want to do is we want to run down our row and do the same analysis. We want to say, hey, okay, for each bike station, what if I took away kiosk 1, what was your minimum distance? If I took away kiosk 2, what was your minimum distance? If I took away kiosk 3, what was your minimum distance? All right. Now what we're going to do is we're going to have to apply something different. We're going to have to apply a minimum function going across columns. We can apply minimum these functions going down the columns. We've done that. But what about if we want to do it row-wise across the row? Right? We need to apply the min function now going across the row. Right? There are several ways to do this. There are a set of functions that can apply to do this, right? Right, and we'll do this in a second. Now, here, the way we're going to set up, this is our STA this table right now. This is what we see. All right, again, using this example. What we're going to do is we're going to create 3 new columns called no K1, in other words, no kiosk 1, no kiosk 2, and no kiosk 3. And then we're going to figure out in a situation where there's no kiosk 1, well, what's your minimum distance? No kiosk 2, what's your minimum distance? And no kiosk 3, what's your minimum distance? And we're going to do it for each bike station. And then we're going to calculate the averages. All right? Really straightforward. Now, how do we use the min how do we apply the min function going row-wise? Well, we're going to start using, well, first of all, you have some of these functions are, I show you the row means and row sums. These are functions built to do row-wise calculations. So it's built into data tables. There's another one called pmin. I don't know why they use p, where p comes from, but basically that also, what it does is it allows you to take a row-wise, it calculates the minimum going across the row rather than down the column. So some of these functions require you to use these cool features from data table called .sd and .sd calls. Right? .sd stands for subset of data. It is a way to apply functions to all the columns or a subset of columns, right? Or to a subset of columns in my data. So for example, if I hypothetically in my table, let's say I wanted the first 5 rows by cluster, right? If I wanted to basically say, hey, give me the first 5 rows of each cluster, how would I do it? Well, we can use the head function directly on the columns, but let's say I want all the columns. That's when you use .sd. .sd is a fill-in for a situation where you want to apply a function to all the columns, right? All the columns, and it doesn't. You don't have, and you don't want to and you can't specify one particular column, so you don't want to specify all columns. It just makes life so much easier, right? So here, right? This now gives you, this will give you all the results right here. It'll give you the first 5 values of cluster 2, 3, and 1, just the top 5 rows. Okay. Same way, if I want to apply a function going across one of these row-wise functions, let's take row means, right? Let's take row means, and I want to apply it across, going across the row to maybe not all the columns, but a subset of the columns. That's when I'll use .sd. But now I'm going to add a comma and use this sd.columns property along with the sd. And in the sd.columns property, I can say, hey, for sd, just give it the second, third, and fourth column. Or down here, I can explicitly give the name. Okay, I say, listen, do the mean for SD, but just do the, K31 column, K32 column, K33 column. Again, I can give the position of the column, or I can explicitly give the name of the column. And if you remember from before, you guys all had that error. I still have to figure out why the hell you got that error, right? For the whole the summary thing. Well, we can use this for the summary command. So if I did sta all the rows dot summary dot sd, and now I say dot sd calls equals k31, k32, k33. Oh, sorry, I have a dot here. Boom. Right? Hopefully, you guys try this out now. Hopefully this works. I remember you guys were getting that error, but if you use .sd, hopefully that worked. Now before, what I was doing when I was doing this, I was putting in dot parentheses the name of the columns that I wanted to. I was wrapping in dot parentheses and calling the summary function on each one of those columns individually. This is so much more easier to do. And it gives you the labels nice and neat. Also, look at that. K31, K32, K33. See? Sweet, huh? So that's how we're going to apply the row means functions to a subset of the columns. We're going to do a mean function. We can apply these functions going row-wise to a subset of the columns. Very easy, very cool. Pmin is actually even easier to use. All right, Pmin, I can just explicitly put the columns I want in it, and it'll do the row-wise means for me. See, this right here will give me the minimum value for each one of for all three columns, going individual row by row. Now we can find the alternative minimum distance. Using this, we can go ahead and do the calculation we want. Right? We can do this, we can do the calculation we want. Now look how I'm going to do the calculation, right? This is why I included a cluster 3 column, by the way. Some of you guys might have been wondering, why did I include a cluster 3 column? Because with the cluster 3 column, I already know what the minimum distance is, right? So what I can do is I can say, hey, right, I already know that, look, if there's, for anywhere where cluster 3 is going to equal 1, K1 is my, K31 is my closest bike station. K31 is my bike station. So I already know that, look, in that scenario, right, in that scenario, no K1 is going to equal, no K1 is basically going to be my, no K1 is basically going to give me the next minimum value, right, the next minimum value. Because K1 is my minimum value, right, K1 is my minimum value. So at this point, all I really need to calculate is no K1. That's going to be the main one, all right? And when cluster equals 2, again, K2 is the closest one, so no K2, I need to just calculate it between K31 and K33. And when I have cluster equal to 3, I'm going to do no K1, no K3 equals the minimum between 3.1 and 3.2. All right? Now, again, I didn't have to do it like this. I could have just, this was just a logical way to do it, but again, I didn't have to do it like this. What I could have done if I wanted to, I could have said, you know what, just do the analysis for all of them. Like for example here, what I did here was I said, okay, just give me the minimum for no K1, no K2, no K3, just make the minimum for each row, just make it the minimum whatever these values are, and just make each one of these the same values, and slowly we'll just change the values. But if you wanted to just follow my example from before, right here I'm going to change the notation slightly, ever so slightly, right? If you wanted to keep it just from my previous example, right? So we can start off with create a new column called no K1, right? And no K1 is just going to be the minimum of, again, I don't have to put any filter here. I don't have to put any filter. It's going to be the minimum of K2 or K3, okay? And obviously, if there's no K1, that's going to be the minimum. Logically, it has to be the minimum. And this will be applied to every row. It's going to be the minimum of either K2 or K3. Oh, I got an error. I have an error. Hold on a second. I apologize. Put the wrong column in. So it's no K1. It's actually no 3.2. Apologize. And no 3.3. All right. And that worked. Now I'm going to do no K2. The minimum, if there's no K2, this will be now the difference between the minimum between no K3, between the first kiosk and the third kiosk, if there's no second kiosk. And here, no K3. This is the difference between the first kiosk and the second kiosk. All right. So this will give you the same results as what I did here. I was just being a little slightly more clever, but it'll give you the same results. Now, let's go ahead and check out the mean averages for no K1, no K2, no K3, right? No K1, no K2, no K3. Now, look, for each one of these columns now, no K1, no K2, no K3, this is now the new minimum distance if one of these if the respective kiosk in the title does not exist. All right, so let's run it. And again, notice how I do the means over here again. I write it 3 times. We're just gonna use my new syntax right here I showed you guys. Right, mean dot sd. You can do either or. I just like this way a little bit better. And this is going to be no k1, no k2, and no k3. Argument is not numerical or logical. Oh, I got a warning.